All right, well, good morning and welcome again. This morning, we're going to look at some more of the features of VMware's ESXi and some of the tools that come with vSphere, specifically dealing with hard drives and backups and disaster recovery and business continuity. So that's the focus for today. And then in today's lab, you will create your first domain. We'll call it the CNET.lab domain. And you'll build a domain controller, a DNS server, a DHCP server, and a file server. And you'll connect that to your Win10 Client 1 machine, or actually you'll connect your Client 1 machine to that domain. And hopefully you have full connectivity amongst all of the features of the domain. All right. So that's the focus of today's lab. Okay. So let me share my screen. I'm going to share the PowerPoint. And let me share screen too. That way over here, I can see if anybody adds the screen there. All right, so let's get this on here. All right, so again, if you have any questions or comments, be sure to pop them into the chat, and I'll try to keep one eye on the chat and the other eye on the lecture. And I'm also looking to see if anybody needs to be admitted to the class at the same time. So hopefully I can multitask well today. All right, so vSphere, as we saw last week, there are a ton of layers to vSphere, right? There's all of those add-ons, all of those additions. And you know, the part we're dealing with is really the core of it, the hypervisor, and the ability to use a virtual environment. One of its greatest strengths and its highest utilization wise, you know, why would we use this, is the ability to have your virtual environment always available, right? We go from high availability to almost perfect availability. Now there's outages, right? Even the big companies have outages, right? Instagram and Amazon, a few times a year, there's something going on. Microsoft with their Azure. But in general, most of the time, these services are available and they're pretty much always available. So we're gonna step through some of the tools that we talked about last week and see how they can be implemented. All right. So one of the biggest areas that a business is going to expect, maybe even demand of their IT department, is that their services, whatever it is, if it's a website, if it's an e-commerce site, if it's a support portal, if it's a programming interface, whatever it is, a video service, whatever they're providing over the internet, the business is, like I said, they're going to expect and maybe even demand their IT staff to make sure that that's always available, right? Your job description is build it and maintain it and make sure it never goes down. So, you know, ensuring the high availability and business continuity is a key part of virtualization. And sometimes, unfortunately, it's not really a forefront issue, but and after the fact. So, there may be a process to select a vendor, either VMware or Microsoft, and everybody decides to do VMware. So away you go. And then after the fact, you're like, well, now how do I make this thing bulletproof? How do I ensure that it doesn't go down? So as well as deciding how you're going to have high availability, one of the key elements, like one of the main building blocks to all of this, is our storage devices and how we're going to build and set up the virtual network aspect of our server environment. Okay, so we're going to talk about some of the tools that are available to provide these services, right? The high availability and business continuity. Now, if we were to define high availability, it means just that it's always available, or it's available at a very high percentage of the time. Then business continuity means in the event of a disaster, a fire, a flood, sabotage, whatever, could be power failure, that the business can continue its operation. So there's a couple aspects that we'll unpack on that. All right. So if we were to look at computing as a series of layers, right? This course, we pretty much defined all of our understanding of virtualization anyway in layers. If we start at the very bottom here, right, we have the virtual layer or the physical layer, which is our physical hardware. So this would be not only our servers, but also any switches, network cards, storage area network, disks that may be external to our system. All of those would be part of the physical infrastructure. And then we have the virtualization layer, which includes the hypervisor. That's the main aspect there. And then inside of our virtuals, we will have a variety of operating systems that provide applications, right? So like, for example, today we're going to build a Windows server, Windows 2019 server. And on that server, we're going to install the role and the feature of Active Directory domain services. And that will allow our other VM, let's say over here is our Windows 10 client VM, it's going to allow it to use the hypervisor and then go through the physical networking, right? From our workstation all the way back to the server, which is also on a virtual, and connect to it and then come back and give us the information that we need, right? So we can create a user account here and then log on to it over here. So it gives us a lot of flexibility with that. Now, when we look at where could a failure occur, right? In general, we're always looking for areas that we can strengthen that may contain a single point of failure. And you'll see that abbreviated like SPF, single point failure. And where those occur is always a good place to either apply the first option is always redundancy. So if there's a switch and we identify this one switch as if this goes down, the whole thing goes down, we may want to have a secondary switch attached to it and then, daisy chain them together so that if one goes down, the other one is connected and can take over. And using the technologies of the switches where they'll fail over and with the trunking protocol and the spanning tree protocol will take and move everything around for us once we have it programmed the right way. Okay, so when we look at the top layer, the application layer, there are programs, like Oracle has, their they have a program, which is called their real application clusters, where you can install Oracle's application on different virtual machines. These could be servers, and if it's a big time application, it's probably going to be on servers, so it's a little more robust. But you can install it on multiple operating systems, even if they're not the same, right? We have Windows and then Linux here. And this application will be aware of the other copies of it or the other installs of it, instances of it, and it'll function as a unit. So their application is aware of the multiplicity of its availability, and it can take advantage of that. A lot of viruses are similar to that, right? You've probably heard of a distributed denial of service, where you have all these zombie computers that are infected with some sort of a rootkit or a backdoor. And when the zombie owner, right, the master says attack, all of these machines in concerted effort will go out and seek out a target and attack it, whether it's Facebook or the city government or whatever they're after that day. So that's an example of an application layer where that can occur there. Then at the operating system, the ability for high availability normally at this layer is we're talking about some sort of clustering. So whenever we say clustering, we're talking about it, what are known as nodes. So each operating system would be considered a node. Now, for the operating system layer, for the clustering work, they have to be the same operating system, right? You can't go Windows 2008 server and Windows 2019 server and then CentOS 8 and Windows 2012. Those are all three different operating systems. If you wanted to cluster them, you would have to repurpose one of these, or to have at least two or more nodes of the identical operating system. And when you do this, there's a wizard in the Windows environment anyway. There's a wizard that will walk you through all these prerequisites, and then it will go out and probe your environment that you've told it about. You add these machines into the cluster setup, and it will probe them, and it will determine if they're usable. And if they're different, even if their network settings are different, it may come back and recommend or suggest that these settings be changed. And what's really cool about it, the Windows version of it anyway, the Windows Server failover clustering, is it will go out and actually make the changes for you. You just have to authorize it. So you say, okay, yeah, go do that. Okay. So normally at the application layer, we're talking about application-based clustering or synchronicity among different appliances that are running applications. At the operating system layer, we're almost always talking about some sort of clustering, and that's there. Okay, and then at the virtualization layer, this is where we can include from our vSphere repertoire of services, right? All those different add-ons, such as vSphere high availability and vSphere fault tolerance that we talked about last week. And then at the physical layer, this is normally where we'll handle the high availability and the business continuity part of this with redundancy. So we'll have multiple switches, we'll have multiple firewalls, we'll have multiple routers, and they're designed in such a way that if one fails, the other one takes over. So, or they may be in a what's known as a load balance, where they're all running at the same time and they share the workload. Okay, and we'll unpack that here in just a second too. All right. So here's a slide that kind of explains that. And as we we'll see here, each of these techniques or technologies has strengths and weaknesses. Okay. Are there any questions or comments at this point? No? I know it's a riveting topic for first thing in the morning, huh? All right, so knowing that some of these things are better at handling certain type of problems versus others, we're going to, as you probably have guessed, is we want to have a wide array and a mix of some of these options so that we can make sure all of our bases are covered, right? I mean, it wouldn't make sense to have our shortstop and our second baseman and our third baseman all standing on second base, right? Because then nobody's over on the third base side. So we want to make sure all our bases are covered. You know, that's where that term comes from. And in this example, you know, or for example, providing redundancy at the physical layer is great, but it doesn't help if the application fails, right? So if we have redundant switches, which is our layer 2 device, right? That's what our clients are going to connect to with the physical layer, right? The connectors and the cables and the network cards are the physical layer. And then they connect to the switches, which are the data link layer, where all the MAC address frames travel and, you know, get bounced around. If we have redundancy there, that's great. But if at the top, if our application is our DHCP server, right? And if that's not configured right, or if it's not authorized, or it's not running, and I'll show you in today's lab how you can kind of check that, it's going to fail even though we have redundancy. So, you know, you might say, well, I did everything I could. Well, you did, but it's only at that bottom layer, at the physical layer. We want to make sure that at where the applications are running, that there's redundancy as well. And then the same thing is true. We may say, okay, I have multiple DHCP servers. They're in a setting where they'll work together. So I have one on this server, one on this server, one on this server. One of them goes down, the other one takes over. That's great. But what if, you know, the cable gets cut between your main network and, you know, your out point of where say the classroom is? That's not going to help you to have redundancy at the top layer with clustering in the application, but you didn't have any redundancy if a line got cut or a fiber optic line went down. So you have to kind of work on these together. So just like anything in IT, there's all of these complexities that have to be kind of unraveled and looked at and determined. Now, the easy answer for all of these problems is just do all of it, right? That's the best way to, you know, ensure that everything is going to be as bulletproof as it can possibly be. Unfortunately, there's a little thing that companies have that prevent all that, and that's known as a budget, right? You're going to hit a certain threshold where they're just gonna, the decision makers, especially the ones with the purse strings, are gonna say, we just can't afford that. You're going to have to get creative and find a way to make it the best possible solution within your budget. So, that's like if you wanted to go buy a new car and you only have, you know, a credit line, or you can only get a loan, or you only have cash up to, $15,000, you're going to be limited in the car you can purchase. Now you can make a good decision, right? You can, look around and maybe go with the used cars that are a brand new car, or, wheel and deal and find a really good solution there. But you're probably not going to be walking onto the Tesla lot or the Ferrari lot or the Corvette lot, and saying, I want the latest and greatest vehicle. And then they'll say, okay, here it is. Here's all the bells and whistles. It has all these features, but the price tag is well beyond what you can afford. So just like anything in life, you have to, kind of figure that out and navigate your way through it. All right. So our focus, at least in this lecture, is going to be on 3 key technologies or techniques that help provide high availability. So that the first one we'll talk about is the clustering feature within Microsoft Windows. So this is a feature that is built into Microsoft's server, and it has been since Server 2003. So it's been around for a long time, and it's extremely effective. It does the job that it's designed to do, and that's the clustering, the Microsoft clustering, server clustering, MSC. Okay, and then the other one we can do is we can cluster our ESXi host machine using vSphere high availability. And then we can also mirror our VMs, right? Have multiple versions of our VMs, one that is an exact replica of the other one. And we can do that using the vSphere fault tolerance. All right. So let's start by looking at the old operating system level and the failover clustering, which is Microsoft's solution to this. Now, this is built in to Microsoft Server. Now, the scope of it, and by scope, I mean how big can it get? Can it scale up or scale down real easily? The scope of it is really designed, if you're going to go with a larger cluster, you're probably going to want to make sure you have the data center version of Windows Server. The standard version is going to have a limit of what you can or cannot do there. Now, because Windows is so widely used, that's why we're going to look at it, because it's very, very common. Now, there's 2 primary ways of clustering. The first is with a network load balancer. And that's exactly what it sounds like, where if you have requests coming into, say, a DNS server. So DNS is the domain name server, and it resolves IP addresses to names. So when somebody looks for, www.amazon.com, the DNS at certain layers will convert that from a name, a human recognizable name, to an IP address, which the computer and the network understand, right? Networks don't understand alpha characters, but they do understand numeric, right? Because they can convert those to binary and away they go. So like a DNS request, it will hit the first DNS in your stack, your IP stack, which is the settings that are handed out to the machine or that are statically assigned in the IP address. And it will try, if it goes to the first one, the next request will go to the second, third, fourth, first, second, third, fourth, and it will just bounce around and in a way of balancing the load. That'd be like if you're at a restaurant and there's, you say you walk into McDonald's and there are 4 cash registers, or 4 places where you can place your order. If it was not load balanced, you'd have to go, everyone just wait at station 1, and station 2, station 3, and station 4 are just kind of waiting there until, station 1 goes on break, and then station 2 takes over. And then 1, 3, and 4 are waiting by. And then they go on break and station 3 takes over. I mean, that'd be very, very unorganized and not very proficient. So the way it actually works is you go up and someone's at 1, you go to 2. Someone's at 2, you go to 3. Someone's at 3, you go to 4. Well, the next person comes in, there's someone at 1, 2, 3, 4, but 1 is almost done. I'll go over there. And if you're like me in the grocery store, you probably pick the wrong line every time, right? You're like, well, it looks like this line's going to go faster. And then you get in that line, someone else gets in the line you were thinking of getting into, but you chose not to. And then they're through the checkout before you even have a chance, right? So that's network load balancing. And then Windows failover clustering is the exact scenario where station 1 does all the work until it fails, or something happens to it, and then it fails over to station 2. Now station 2 is doing all the work, and then node 3 does all the work, and then node 4, and then it will just bounce around as the nodes are available to do that. Okay, now each method, the network load balancing and the clustering server, the failover clustering, they serve different purposes. Now, the load balancing typically is used when we want to scale our performance, while the failover clustering usually is focused on providing redundancy and the high availability in the form of an active passive workload clustering. Now, some experts say that vSphere high availability eliminates the need for Windows Server failover clustering because it can provide failover in the event of a physical host failure. But as we mentioned, in those layers, we want to make sure we're doing something in the operating system layer. So whereas the vSphere HA would be at the virtualization layer. So we want to be in there. So at the operating system layer, it provides redundancy in the event that one of the operating system instances in the cluster fails. So that operating system failure could be the result of hardware, and vSphere HA, that should be an HA, not an FA. High availability and fault tolerance operate at the layer beneath the operating system and don't operate in the exact same way. So if it's a hardware failure, the high availability may not even work if the hardware is damaged. Okay, so different versions of Windows will have the ability to do, all of them will do the NLB, or the network load balancing. And this, we just put under this table Windows Server 2019, 2016, and 2019, and it has the same number as 2012. They'll all do network load balancing, and you can build up to 32 nodes. So you could have 32 redundant DNS servers, 32 redundant, DHCP if you wanted it. Okay, now the failover clustering is only available in the enterprise of Windows Server 2003 and 8, and then they change the name to data center, where it goes up from there. And you can have up to 64 nodes with the data center version. All right, so the ability to cluster is a very important part of all this. Now, the network load balancing is based on what are on the concept of stateless services. So stateless means it's not really in a state. It's just the information that it gets from the server is relatively static at that time. So it's not in a state. It's not like, well, that's the state it was in right now. 2 seconds later, it's different. 2 seconds after that, it's different again. So like, for example, a database server is constantly changing its state, right? The data is not relatively static. Even in if we just measure its state in seconds, it's changing, or sometimes even, milliseconds or nanoseconds. So that is something that we would probably not want to do with an NLB, is something that is changing frequently. So in a typical network load balancing cluster, all nodes are active participants in the cluster, and they're constantly responding to requests for services. So like if you call the hotline for, your game on your PlayStation 5, you call Sony and you're having a problem with it, you're probably calling into a phone bank where there's a multitude of customer service reps, and the phone rings and it just goes down the line until, someone answers it. It's not the same person each time. So that's like a load balance. Now, in one of the nodes if one of the nodes in the network load balancing cluster goes down, client connections are simply redirected to another available node in the cluster. So if you're in line at McDonald's and they're doing a network load balance, and that person, they flip their sign and say this station is now closed, you just move over to whoever's open, the next available service. Okay. Now, NLB its purpose is to deal with speed, network performance, enhance our performance, and increase the availability. And there are certain services, we talked about infrastructure services, and that's exactly what we're going to build today in our lab. And the big one in that is DNS, the domain name server. Because if our clients and our servers cannot communicate based on names, it's going to be very, very difficult to keep a bunch of IP addresses organized in your head. If I were to say, okay, open a browser and go to YouTube, but only do it via IP address, there's probably nobody on this meeting right now that could say, well, I know the IP address for YouTube, and just type that in and get to YouTube, right? We're creatures of, we're good with names, but not with numbers. I mean, some people are, but typically. Okay, so some of the services that work well with network load balancing are stateless connections and services, such as our web server, our virtual private networking, and then our firewalls. That data, that information is relatively static, or the connection is stateless. All right, any questions on the network load balancing? I don't see my chat, nothing in there. Okay, maybe not now. Good. All right, so let's go to the next slide here. And so here's a graphic that shows a network load balancing where it has a load balanced identity. So this would be like a load for a web server. So our web server has this www.lab.local. That's a web page but it's actually hosted on 5 different servers. So this data, so whatever the web server settings are on VM1 is identical on 2, 3, 4, and 5. So like when you go to ebay.com, there is not a single eBay server. It's a whole bunch of servers that are out there that share the data between all of the information. Now, eBay is a good example of their web front end is probably network load balanced, but their database backend, where all the information is stored about everything that they have on auctions and the times and all that stuff, it's on a failover clustering. So it's a combination of 2 of them. Okay, but typically the front end looks like it's a single site, but in the back end, it's going to be load balanced with the cluster. All right. Now, unlike network load balancing, the Windows Server failover clusters are used entirely or solely for the sake of high availability. So that means that they're not interested. Their purpose is not to improve performance. If you want clustering to improve performance, that's where you're going to look at the load balancing. If you just want to make sure it's always available, that's where you'll do the failover clustering. Okay, so a typical cluster will include multiple nodes, but only one node owns the resource at a given time. So with Windows Server failover clustering, they're going to be used with services or applications that have some sort of common data store. So like SQL Server is Microsoft's database server, and it will include our SQL databases that consist of tables and forms and queries and reports and all the stuff that go with database administration. And the data itself is stored in a large, complicated file known as a database. And whenever we have shared data, that's typically going to be deployed on a common data store. Now, we built a data store in week 2 or week 1, I forget which week we started with the data store, but it's on R1 machine, right? So your DS1, which is our data store in ESXi, is on your host machine. So if your host machine has a hard drive failure, everything is down, right? We have no redundancy there. We have no failover. We have no load balancing. We have no application clustering. We have nothing. So if your server goes belly up tomorrow morning and you try to get into it the next day or later that day, you're going to have a problem. Now, we will add in a future lab where we will create a data store that's going to be hosted on an iSCSI network, and also another one that's going to be hosted on an NFS server. And those are shareable data stores. Your data store is not shareable. You cannot say to another user, hey, why don't you put your VMs on my data store? I'll make it available to you. You can't do that, right? It's a one-to-one relationship only. Okay, so when we have a common data store, it houses the information accessible by the node that is online and currently owns the resource, as well as the other possible owners that could assume the ownership in the event of a failover or a failure. All right. Now, each node or each machine that's part of the failover clustering has to have a minimum of 2 network connections, and typically it'll have a 3 network connections. Okay, so one will be for the production network, that's our client side. One is for the heartbeat network, which is just between our two nodes. So node 1 and node 2, node 1 is the one doing all the work right now. Node 2 will say, hey, node 1, are you alive? Send it a ping. If it comes back with a reply, okay, he's online. Ping, reply, he's online. And it'll do this at a certain interval, normally, every couple seconds or, every second. And so node 2 is just sitting there waiting, and ping, you're online. Ping, you're online. Ping, no response. Ping again, no response. I'm taking over. So now node 2 is the one that is available, that it now takes over the resource. So node 1 had the database connection. When it dies, when it's no longer available, node 2 says, give me that connection, and away we go. And all the data is still up to date, and it can serve the network very well. Okay, so those are the kind of the principles of our network. Now here's a typical network diagram that shows failover clustering. So on our private network, here's our heartbeat network, and each one of these cables represents a separate network card, which will be on a separate network ID, which will be connected to separate network equipment, the network card and the switches, or the fiber optic connection, or the fabric for the SAN. Now the shared network, the public network, this may be gigabit or 10 gigabit, whereas the private network can be 10 megabits if we wanted to. Probably be at least gig, but it doesn't need to be a high speed network, because all this is node 2 says, node 1, are you there? Yeah, you're there. Okay. Node 2, are you there? Yeah, you're there. Node 2, are you there? Nope. Node 1, are you there? Nope. Node 2 then says, give me the data, and it will continue. Now out here on this end, this is where our clients connect. So our computer on the work network is connected to the public network, and we're using the services that are provided on this machine. So if this is a file share, and if node 1 is serving it, right, it's the current connection, it's the active connection, and this one would be called the passive connection. When the active is active, all the data comes through this machine to us. So everything goes from the data store to the server to the network, and then vice versa. And then when it fails, the client doesn't really care as long as the data is still available, it could care less where it came from, right? How did it get there? It really is irrelevant to the end user where the data came from, as long as it's the correct data, as long as it's the correct stuff, and then we're happy. Okay, so any questions on the Windows Server failover clustering? All right, so far so good. I'll just keep on it going as long as nobody stops me. Now, when these failover clusters or server clusters are constructed properly, they're going to provide automatic failover services and applications only hosted across multiple nodes. And it can do that because only one node owns the resource at any given time. So if we go back to this previous slide, if this is my database, I cannot have node 1 can't own the database and node 2 can't own the database simultaneously. Because have any of you ever worked on a file, or you try to open a file and it says this file is currently in use by another system or another user that's logged into your computer? So say you're sharing your computer at home and somebody opens a file on their end, and then you switch users and you open the file, you'll get an error, or not error, but a warning that says this file can only be opened read only, which means that the content is static. You cannot change it. It cannot be dynamically changed because it's opened by another user, and they basically own that file. They can they have full permissions to it. You only get read only. Okay. So it's important when we're talking about this failover clustering to understand that, because if only one node owns the resource at any one given time, if the owner goes down, the clustering software and the clustering setup has to take into account how that will transfer over to the other user. And that's what the clustering system is designed to do. Okay. Now, here's some of the basic requirements for clustering in a Windows environment. One, the nodes have to be running enterprise or data center editions. And all the nodes should have access to the same storage device. So that's coming back here. This is saying they all have to have access to this data store. So that means they have to be networked to get to this SAN. Typically, it'd be a storage area network. Okay. All nodes should have two similarly connected and configured network adapters, one for the production or public network and one for the heartbeat network. And they have to have the Microsoft cluster services installed and configured. Now, the nice thing about these nodes is we have to install it on each machine, but we only configure it in one spot. Once it's set up properly, the one node can push the information to all the other nodes. So we only have to install it in one spot. And when we turn it on, we enable it in everywhere, and then we configure it in one spot. Okay. Now, there are some techniques for clustering, and I'm going to get to this in just a second, but I'm going to stop my share for just a little bit. And I want to ask, have any of you been aware of or participated in any kind of network load balance environment or a server clustering environment? Do any of you have experience with that? Okay, not, Ian said not that he can remember. Robert says not really. Luis, no. Okay, well, one of the things we're going to do later on is we're going to build a cluster, and we'll set that up in a way. Okay, the data store is on cPanel, right? That's the web front end where you can configure your hosted web server. And yeah, that's a good location for where you'll find data stores. So we're going to build a cluster in a future lab. And remember in the beginning of this course, I said, we're going to have some labs where there's, 7 to 8 to 9 virtual machines running and 4 or 5 different services running all at the same time. When you cluster, it gets extremely complicated, and we'll have 3 different networks and 3 different network cards and on 5 different servers and 2 different clients. I mean, it can get pretty complicated pretty quickly. But I saved that one for later in the course when you're much more familiar with the ins and outs of dealing with these things. All right. I'm going to just take a couple of minutes too and ask, did anybody have any problems or gotchas or, moments of clarity on last week's lab, right? Where we did the routers? Anybody want to share their experience? I mean, because normally if we were face to face, if we were in a classroom on campus, I would always reflect on the previous lab, because sometimes, you submit it and you're not 100% sure, what did I just do? I think I got it right. And then you get your score back and, maybe you missed a point here or a point there. And we don't have that feedback time after you submit it. I mean, but I want to make sure that you feel like you have a voice in what we did in the previous week's lab. Okay. As far as I remember, everybody got both of the routers to route properly, whether it was the firewall service in CentOS or the routing remote access server in the Windows environment. Yeah, and depending on your experience level, it may seem a little overwhelming at first, but you'll just hang in there. You'll get it. I do want to mention that several of you, and I'm not going to point you out, but there were a handful of people that lost connectivity to their host machine. And when I say host machine, I'm talking about the machine you connect to with the Apache Guacamole. And that machine, what happened is it's confusing sometimes to look and figure out which network card, what network settings are you in? Are you in the Windows 10 client? Are you in Windows Server? Or are you on the machine that you remote into, right? The host machine, the CNET58, the Win10-CNET58-1 or 3 or 20, whatever your machine number is. So what I've done is I've gone in, I logged into every single one of our Windows 10 CNET58 machines, the one you guacamole into, and I changed the network ID or the network name so it says do not change. So if you're ever on a network adapter and you look at the settings, so here I'll show you what that's going to look like. So let me share my screen real quick. I'm going to share screen one. So here's my home computer. If I come into my network settings, you'll see now I have several of them going here, but I renamed your Ethernet, which those machines only have one network card. So if you're working in here and you see this do not change, that means do not change it. That means you're in the wrong spot. So be careful if you're doing anything in your networking. Take 2 looks. Have any of you ever worked with carpentry, right? Woodwork. There's the carpenter's adage that says you measure twice, cut once. I want you to kind of take that same approach where you're going to look twice, make sure you're on the right machine. Now, I got a great suggestion from one of your classmates, Robert Polanca. He said that instead of opening those virtual machines in another tab, just open it in a new console, a new browser console. And that way it will form fit it so it's obvious you're in one machine or the other. And the other thing that fixes, because some of you had this problem with the mouse being all squirrely, right? You would want to click here and it would actually, the mouse would be, off by an inch in where it was in the virtual machine. So if you open those in a new console, browser console, that's going to fix that. Okay. Yeah. Alan said that he accidentally changed the host machine's IP address, and which wasn't, I mean, it was easy to fix. I just had to go to campus and get permission to go on campus, fill out the health form, all the paperwork that goes along with that. Then I went into 405 and just where your machine was still on and it said, you made the changes. I just hit cancel and then it went back and everything was fine. But that did mean I had to get in my car and drive to campus, which took a little bit of time for me to do the next day. All right, so let's stop here. We'll take our first break, and let's come back at 9:05. So about 10 minutes from now, and then we'll continue looking at these clusterings, and we'll get into some specific technologies and techniques in the clustering. So not only can we cluster, but there's some ways where we can put the cluster in our virtual environment that can help us out along the way. All right, so let's take a short break. I'm going to stop the recording. All right, so let me share my screen again. And I want to share or show you, here I am logged into my virtual machine with the guacamole. And if I go into my network settings on this machine, you'll notice it says do not change. So if I come into the adapter options, it will say do not change here as well. Okay, so if you ever see this, do not change it. All right, and then the other thing, and I'm going to talk about this in today's lecture or today's lab, is your guacamole will automatically put a black background. So if you just look at the machine you're on, and that's sometimes easier said than done, but it will have a black background. And then in your VMs, so here I am connected to my ESXi server. If I go into, say, Windows 10 client, so here I'm going to power it on. And then if I go console, open browser console, see how it gives me this nice border? And my VM will only be in this window. And then if I minimize it, it just sticks it over here in the corner. And I can pull that back up like that. And I can close this and everything. If I just click on this window, it automatically open it in the browser. So let me log on here real quick, and I want to show you. So now it's clear that this machine, right, is different than this machine. So if you're changing these and somehow you end up on this one, it will say do not change. If you see that, go, oops, wrong one. And now come into this one. And now this one just says Ethernet. Okay, so it can change adapter settings. And it just says Ethernet 0. So hopefully that will keep you from getting too confused. And then the other thing I want you to do is on your VMs that you're using, go into the background, personalize it, and change it from a picture to a solid color. And pick some nice bright color, you know, something that will kind of get your attention. So maybe a plum, that's a good one. So whenever I see a plum, I know that's one of my VMs. If I'm working on my host machine, if I minimize and I see black, that means I'm on my guacamole connection. All right, so I'm gonna leave that there for now and go back over to PowerPoint. All right. So if you have any questions on that, just let me know. But one of the techniques that we can use with clustering in a virtual environment, there's 3 of them. One is called a cluster in a box. The other one is cluster across boxes. And then the third one is physical to virtual clustering. Okay. So the clustering in a box is where all the VMs are on the same host server. So the same ESXi host. And as you can imagine, having 3 or 2 or 3 or 4, however many machines you have that you're clustering, if they're all on the same host ESXi server, if that server goes down, your cluster goes down, right? If we cluster across boxes, that means that the VMs are running on different ESXi hosts. And that gives us a little bit better redundancy. And then the physical to virtual is where the physical server is clustered with a virtual machine on another machine, on a ESXi host. So our server 2012 doesn't care where or what server is running on, as long as it has the same version, and it's capable of running the cluster. All right. So a cluster in a box is exactly that. Everything is on the same box. So it's all on the same ESXi host. So everything is virtualized inside of our ESXi machine. And as you can probably figure out, if this machine goes down, boom, boom, both of these virtuals go down too. So all that redundancy, well, let's cluster, we'll make sure, but if the host machine goes down, we're in trouble, right? It's kind of like if we build out our network in our building, but then our building goes down, it's all for naught. Now, there is a single point of failure, right? We're always looking for the SPF. And in this case, it's the ESXi host machine. Now, this architecture contradicts the very reason to create failover clustering, right? We want to build clustering. Now, why do we, someone answer this question, why do we use load balancing? What is the benefit to load balancing?
Performance and availability.
Exactly. So load balancing improves speed and performance. And then why do we use failover clustering? What is the only reason we want to use failover clustering?
Availability.
Availability, exactly. So if all of our machines are on the same box and it fails, we have no availability. We're in trouble. Now, this can be used for learning or testing the configuration. Is a very easy way to, like, for example, when we do our clustering lab, it's going to be on the same server. It's all going to be on the same ESXi host or Hyper-V host. So that's not best practices. That's bad in the fact that it doesn't really give us high availability, but it's good for us to learn how to do it. Because a lot of these technologies are something you may only do once every couple of years or once every 10 years. So you're going to have to, knock off some rust and sharpen your pencil and figure out how to do this. And it would be very, very time consuming and resource intensive to say, well, let's get 3 different servers, set them up as a test environment, whereas you could just do one in a virtual and away you go. You could even do this on, your workstation virtualization if you wanted to. Now you can do this if you have planned downtimes or patching. So that would allow that to happen with the cluster in a box. Now the cluster across boxes. This is a very solid solution that allows us to meet our stringent uptime requirements. For example, the enterprise level servers and services like SQL Server and Exchange Server. An Exchange Server is Microsoft's mail transfer agent, MTA, that are very heavily relied upon by all users, right? If you're in a business environment and your finance department or your registrar's office or your division office, wherever you're at on campus, they're going to need access to a lot of data, right? They're constantly pulling data, student schedules, faculty schedules, office hours, and all this stuff. They're trying to figure it out. And most of that stuff's stored on a database, which means that data has to be available. If the database goes down, people are just sitting at work going, well, what do I do now? I mean, I can't organize my files anymore. I've done that before, last time this happened. So you really want to make sure those things are a high availability. Now, the clustering across boxes draws its high availability from the fact that the 2 nodes in the cluster are on different ESXi hosts. And then the idea of this is that the VMs must have access to the same shared storage. So that storage area network is outside of your ESXi systems. So this SAN, this storage area network, this disk is separate from our host ESXi, ESXi 6 and ESXi 8. Okay. That way, if this machine goes down, the data store doesn't go down with it. And vice versa, if this one goes down, same thing. So this can fail over and away we go. So the clustering across boxes gives us the desired high availability, which is why we're going to cluster in the first place. Okay. Now, physical to virtual really isn't a technique that is, I mean, it can be used, but typically, if you have adopted virtual technologies, you're probably going to be able to do the clustering across boxes. But you could, if you had to use an existing production server that's standalone, it's not virtual, and it doesn't matter. The system, the software, all of it is going to function exactly the same. Okay. Now, the advantage to implementing physical to virtual is the resulting high availability with a lower cost. So you don't have to pay for the licensing to have two ESXi or to have, you know, the functionality of the ability to do that. Now, remember, all of this is at the operating system level. Okay. At the physical layer, what do we use at the physical layer to ensure some sense of high availability and business continuity? What do we do at the bottom layer? Anybody? You'd have to go back about 22 slides, 23 slides. It's the redundancy, right? At the hardware layer, we would have redundancy. So if we were to look at this shared data store, we may have in this SAN, it's going to have multiple, 15, 20, 25 hard drives plugged into this on a RAID controller that will allow this data store to suffer drive failures. So if one hard drive fails, we don't lose the whole data store. It's still available. And that's because it has redundancy built into it at the physical layer. Okay. So we can cluster outside of Windows, right? There is a project in Linux called Beowulf, the Beowolf, and it's been around for a long, long time. And it allows you to cluster your Linux devices. There's actually a clustering project that you can take your Raspberry Pis. So say you have 20, 25 Raspberry Pis, you can cluster all of those together and build a quote unquote supercomputer. It's still not going to have a ton of processing power, but it's greater than a single Pi for sure. Okay, so other operating systems have the ability to do this. We focus on Windows because that's what most businesses are going to be using in their server operating systems. Okay, so now we talked about the physical layer, right? The physical devices, that's where redundancy is. At the operating system, that's where we have our clustering, our load balance, network load balancing, NLB, and then the WSFC, the Windows Server failover clustering. If we go up the next layer into the virtual virtualization, actually physical virtualization and operating system. So we skipped virtual and went to the operating system. Now we're back in virtual. This is where we can look at some of the features that we can add to our vSphere system. And this is specifically the vSphere high availability. So that's a component of the product that provides for automatic failover VMs. So with high availability, if a host machine and all its VMs fail, those VMs are moved and restarted on another host machine. Okay, just like this picture shows. So if this one goes down, these VMs, boom, they're moved over here, and whatever else was there is also running, and they will start up and run there. So the high availability is designed to deal with ESXi host failures. So it's the hardware failure at the virtual layer. So when the virtual system itself goes down, it will help us with that. It can also help us protect against virtual machine failure, so the operating system, and at the top layer, at the application level failures. But in all cases, vSphere uses a restart of the VM as the mechanism for addressing the detected failure. So it has to move it and then restart it. And that means there will be some downtime. So the time it takes for it to start up and to move and restart will it's going to have some downtime. So this is not a perfect solution. All right. Now, high availability is only part of the solution. One component in the bigger picture known as is business continuity. So business continuity ensures that the business can continue operating in the face of some significant event. So those events could include natural disaster, man-made disaster, accident, whatever it may be. Okay. Now, high availability deals with business continuity in a very narrow perspective. So it ensures that the business can continue operating in the event of a physical server failure, an operating system failure, or an application failure, or a network component failure. It cannot deal with the entire enterprise failing, right? So normally in a natural disaster or some business continuity environment, it's a widespread problem, right? It's a brownout or a blackout in all of Southern California. Well, if our servers are designed with high availability, say with the VMware vSphere high availability, it's just going to move from one ESXi host to another. Well, if all the power's out in Southern California and all our data centers are in Southern California, guess what? We have no, our high availability will not do anything to help us there. So we have to keep that in mind. Now, the further up we go to solve these problems, the greater the cost. And as I mentioned last week when we did our sales pitch on vSphere, there is a product that allows you to replicate your entire site. So that would mean that everything here in Southern California could be moved and restarted in our, Sweden location, or in our Hong Kong location, or in our Johannesburg, South Africa location, wherever we are in the globe, we could do that, but that is at a very, very costly price tag. Okay. So it's hard to plan for business continuity. I remember when I was an IT director, I had this guy who just cold called, right? Salesperson just stopped in, didn't make an appointment, just said, I'd like to talk to your IT director. And he came back and he said, I deal in mobile sites. So what we can do for your company is we can come in and do an inventory of all your servers, all your applications, all your systems, and we can build an exact replica of everything. Whatever server hardware you have, we'll buy the same thing. we'll put it on a trailer, like one of these big trailers, and bring that in the and if your site goes down, we wheel in the server powered up and you're back up and running. He says, that's something you'd be interested in. I said, yeah, I'd be interested in that. Can you give me a price? Just a ballpark. He said, well, looking at your environment, looking at what you guys are doing, it would probably start around somewhere between 1.75 and $2 million to do it. And I said, well, I can tell you right now that there's no way our company is going to pay for that in the event of a catastrophic failure of our campus. Would that be worthwhile? I mean, I doubt that Mount SAC, which is much, much bigger than where I used to work, that they would consider doing that, because they're bigger, their price tag's going to be much higher. I mean, but take a company like Amazon or, you know, any of these e-commerce sites, a couple $1 million, even $10 million is like 10 minutes worth of business. So they would say, yeah, we need to have that. We need multiple of these. Let's have one parked over here and one over there, one over there. And in the event, just flip the switch and we're back up and running. So it depends on what you're trying to do and how much budget you have. Ian mentioned that there's been fires in server rooms, right, that have caught on fire. That can happen, right? And depending on the data center, right, the server role, the hot aisles, cold aisles, and then the fire suppression, which by code they have to have that in their data centers. If they don't, I mean, if just kind of a ma and pa data center where it's not, you know, inspected or approved by the fire marshal, then there could be catastrophic fire and failure there. Because what happens if this data or our server goes down? So let me go back to where we have a server here. If this host machine goes down and we don't have another one to launch it on, what is our only recourse here? I mean, we don't have it set up to go anywhere else. If it fails and all this stuff is gone, it's gone, right? Unless we have what? Have redundancy. And in what type of redundancy? What are we specifically talking about? Okay, physical redundancy, okay. But we need some sort of a backup, right? That data has to be backed up somewhere. And if it's not, you know, then you fall into the category of the guy who walks into the data recovery place with his old hard drive and he sets it on the counter, and the technician says, there are two types of people in this world: those who back up their data and those who wish they had. And because you're standing in front of me, you're probably in the second category, right? I mean, if you don't back up your data and you lose it all, you'll be, you know, kicking yourself, and you probably be in the unemployment line if you work in IT, and take it from there. So you've got to have backups as well. All right, there's a question in the chat: is redundancy always RAID? No, it doesn't have to be. You could have redundant power supplies that aren't based on RAID. Now, RAID is redundant array of independent disks. Specifically, RAID is redundancy for hard drives. But we can have, some servers have RAID for their memory banks as well. So have multiple banks of memory in their server, and they work in concert. If one fails, the other one takes over. So it can handle it that way. But we can have redundancy with our switches. We can have redundancy with our network cards. We can have redundancy with our firewalls. We can have redundancy with our internet connection, right? And they may work side by side together, or we may even combine them into a teamed or a aggregated bandwidth. And then if one fails, it just operates at the half the speed. But there's a lot of places we can do redundancy. All right. Now, the two primary types of failures that also must be protected against are protection against data loss due to equipment failure, software malfunction, or simple user error. And simple user error could be as simple as somebody saying, I was working in a file and I thought I saved it, the original file, I thought I did save as, but I actually redid the file and then saved it with the same name, but I need the data that was in the original name. That's just a simple user error, or, you probably heard the old adage of the person who said, I noticed I had all this data on my computer, so I deleted it because I didn't know what it was. And turns out they deleted it from, say, the network share. And now everybody's going, where did all this stuff go? So, there could be simple user error. So there's that type of protection. And then ensure that you've done the necessary workaround planning for disaster recovery in the event your entire data center is rendered unusable or unavailable. And to be honest with you, it's this type of thinking, these kind of planning and scenario-based situations where you go over in your mind, when you're in charge of the entire data center, you're in charge of all the data in your company, and it will keep you up at night going, what if this goes down? What if this system fails? And the one, this is going to sound crazy, but the one that kept me up, gave me the most thought, wasn't anything to do with the data, because the data I had backups, the data I had offsite backups, the data I had backups of the backups. So I knew the data, if something tragic happened, within hours or maybe a day or two, I could have everything restored and we'd be back up and running. The thing that I just had no solution for was our old phone system. And the reason I say that is because there were no backups of the voicemails. And when you work in a business, you're not just dealing with business phone systems, right? There was one of the instructors, one of the professors there, and he was telling me how he had worked there for like 15 years, and he had saved all the messages from his son. So he had a phone call from his son when his son was just like 2 years old, just barely learning to talk. And, I miss you. And then he had him when he was 2 and 3 and 4, all the way up. And he asked me, he said, hey, Ken, is there a way I can take those voicemails and put them onto a CD or something? Because I want to make sure I never lose those. Because we were talking about, changing the phone system in the next 6 to 8 months, 6 to 12 months. And I said, I don't know. I said, in fact, though, all those voicemails, they're not even backed up, because the system that we had, it had, what it had for a backup system? A floppy disk. That's how old it was. So you could back up maybe the phone settings, but as far as the voicemail messages, the data on the voicemail system, it was ancient, but it was still in use and it still worked. And ever since that conversation, I was always thinking, what can I do about that? So I called the company that supported the phone system. They were still around, and they said, well, the only thing you can do is have him play all of his messages and have a microphone and a recorder next to it, maybe like an MP3 recorder, and record them. And that's the best solution that they could come up with. So now the new systems are all voice over IP, so it's just data. So we can back that up very, very easily. But those old systems, it was crazy. So what would have happened if, and that was just one person on a system that had 500 users. What if all of them had that same problem? I mean, now we're talking a major situation. Okay, so the solution to do this is we need to have policies that define processes, procedures, tools, and technologies that help address any of these failure scenarios. So, sometimes you have to put on your gloom and doom thinking cap and say, what if, right? What if there was a flood? Like I remember a couple years ago, I was watching the news and there was a water main that broke downtown LA right next to UCLA. And all this water was going down this street. And then it went down into these steps into this one building on campus of UCLA. And it filled up the bottom floor, which was, like half a story below ground level. It filled up that thing. And it was some data office, and the guy said all of our servers are in the basement. All of them are underwater right now. And my first thought, is hopefully they had those things backed up, because it's not going to fail over. I mean, if your server is underwater, it's not going to automatically switch over to the next server, because it's going to just short out and turn off. So you start seeing stuff like that, and they don't recommend you put your file servers on the top floor either, because in the event of a fire, you're not going to be able to get up there either. So not in the basement, not on the top floor, not on the first floor where you get a lot of traffic. But you have to think about all this stuff. Where can we put these things that will, in the event of a natural disaster? I mean, it's a lot to think about. Okay, so backups are an essential part of every IT department's responsibility, yet they are often the source of the greatest conflict and frustration. Now, there's kind of this ill-conceived idea that if we virtualize, we don't have to worry as much about backups. And that could not be further from the truth, because now, if you have a physical machine, it's easy to walk by that physical machine and say, okay, I need to take my removable hard drive and attach it to that machine and run a backup. And I need to schedule that, once a week or once a month, and have a technician go by and do that, or have someone in that business unit do that. But your virtuals are kind of out of sight, out of mind, right? They're just clicks. You just click them on and click them off inside, or you remote into them. You don't even see them physically. So it may be kind of hard to do that. So in some ways, having virtuals can make backups easier, and in other ways, it can kind of hide it. So it cuts both ways. So there are 3 high-level methods of backing up VMs in a vSphere environment. The first is the same way we would back up any operating system, and that's with what's known as a backup agent. So with our operating system, so if you're using Windows, right, and you can go into your backup settings, and like here's on my machine. So I just went into my settings and then the backup, and my machine will automatically back up your files to another drive and restore them if the originals are lost. And the reason and how this works for me is I just have a 3 terabyte USB drive attached to my computer. So whenever I make a change on my computer, once a week, my system will go through and say, has anything changed? Let me update my backup. So I believe it's every Sunday. Let's see if it shows the schedule here. No, it's not going to show. But anyway, that's with the client based backup, which is known as a backup agent. So that's using the built-in backup features in Windows. So all of our Windows machines have that. Now, the other thing we can do, we can purchase backup systems, or we can, there's open source solutions. One of my favorite names in all of this backup environment is a system for Linux called Bacula. So Bacula, it sounds like Dracula, right? Bacula, and one of their things, let me see if I can find their website. So there is Bacula, and man, I clicked the wrong link. Bacula.org. And it's a open source system. And they used to have a tagline on here where it says, "We want to suck your data," or something like that. So when it first started, they were a little more cheesy, but now they've grown into this bigger system. But what this does is you install a Bacula server, and then the server will you just tell it which clients do you want to back up. So you just install this little tiny program on the client machine, and it just allows it to communicate with the Bacula server. And depending on how you set it up, it will just go and do the backup for you at scheduled times. Okay, so that's Bacula, one of my favorite names in IT. Okay, so that's running a backup agent. We can also use snapshots. And then we can also use a storage array based snapshot integration. Now, some of these systems are going to be better than the others. So here's our backup agent. So we just install the agent, which is an application, or we configure it on the virtual machine, just like we would on a regular machine, and it will perform the backup. And then we just configure it to back it up to a target location or put it on a shared data store. Okay, so that's a typical backup agent setting. Now, running a backup agent within the guest affords your operating system and application level awareness and integration. This allows a backup agent to perform very granular backups, such as specific tables in a database, particular mailboxes, or a subset of files within a Linux operating system. So you can tune this in as finely detailed as you want it to. Now, the drawback to backup agents is one, it is going to add more traffic on our network, right? So both our virtual networks, if this machine is doing a backup, between the host machine and the backup target or the shared data store, it's going to take traffic. So if it's on the same network as our clients, so if it's on our production network, that's a bottleneck. So what do we do to fix that? We say, well, let's do our backups at night. Let's do our backups when nobody is using our systems, right? Where the bottleneck's not as big a deal. Well, that's all well and good unless you're in an environment that really is 24/7, 7 days a week, right? 365 a year. It's not going to, there is no downtime, right? Your business processes move with the sun. So it moves from one time zone to the next, to the next, to the next. There's never downtime. And if that's the case, then when do you do the backups? And then to avoid the bottlenecks with end users facing traffic, you can have dedicated backup networks. This means more network cards in the host machine, the ESXi host, separate V switches, separate physical switches, and more complexity. So your switching network and your traffic network gets extremely complicated, which is doable, but it's something that you have to consider. And of course, you have to configure all that stuff and buy all that extra stuff. Now, backing up a VM can often take longer And some backup vendors charge a separate license for each installation, which has decreased the financial benefit of virtualization, right? Remember a simple orange monster: availability, scalability, optimization, and management from last week. Well, if the cost, right, we're virtualizing in some respects to save licensing costs, to save power costs, to save cooling costs. But if we have to pay for backups, additional backups, then that may be a problem area. All right. So the next option, right? We had backup agents, then we had snapshots. And snapshots are a great way of capturing a system at a point in time. Now, when you do a snapshot, it doesn't involve a lot of processor and memory, so they're fairly quick. They don't take a long time. And then there's little or no coordination with the applications running in the VM. So it doesn't provide the same level of backup restore granularity of running a backup agent. So if I just take a snapshot, so if I come into my ESXi host here, which I don't know why I closed that, but so if I come into my ESXi machine here, and I look at my Win Server DC, which is the one we're going to create today, then if I just right click and click on snapshots, take a snapshot, it's just going to make another hard drive file. Okay, so this will make a separate hard drive file of that machine's VMDK hard disk file. And it will timestamp it. So say this was at 9:47 a.m. on March 23rd. And if I want to restore a file, so if let's say that's our server, our file server, and a user calls and says, oh, I accidentally deleted this file that was on the file share. Well, the only thing I can do is I can only say, well, I can bring it back to where it was at exactly 3:23. And that will restore that person's file. But anybody else that made changes, they're going to get lost with it. So we save one and we lose, 20 other ones. So you kind of have to, that's not a good solution for individual files. Now, for a bigger system, it's a good idea. Okay. So, and you may require you to restore the entire VM rather than restoring a specific file. Okay. So there's that problem there. All right. Now, vSphere also offers vSphere replication. So this is where we take a copy of our entire data center and moves it to another location. So we move it from Southern California to, the Pacific Northwest, or we move it to, Japan, or we move it to, pick a country wherever we have business in. This is obviously the most expensive option, but it is available. It is something we could do if we wanted to. So when your boss says, hey, we need to do this, this, and this, and they're using general terms, when you come back and you push back and say, okay, this is, you wanted to do this is the price of it. Then they'll probably go, well, that's not what I meant. I meant, can we, and they'll start speaking in terms that will fit within the anticipated budget. So there are always these wish lists and then price, and they're kind of mutually exclusive. All right. So here is our site that's, this could be anywhere in the world, and we can asynchronous replication, which means we have to copy it and then send it. So it's not synchronous. That doesn't mean that it's constantly updating this other site. We have to update this site and then move it over. And this can be extremely costly. But if we want, to make sure that we never have downtime This would be our most holistic approach to doing that, because this type of the vSphere replication, it's going to handle physical errors. It's going to handle, so our data store here, it's going to handle the operating system. It's going to handle the virtual area, and it's going to handle the application area. So all those areas that we want to make sure we have some sort of high availability and clustering and business continuity for, this will be the best solution for that. But it's by far the most expensive. Okay, now let's stop here. This is a good spot to stop, and then we'll take the last hour and talk about vSphere security. Right. So I'm going to stop my share. And so when we come back, we'll talk about some security issues, and I'll mention a couple of things that we probably could do if we were in a production environment, not in an education environment. But let's take a 9-minute break. Let's come back right at 10 o'clock. And then we'll keep going through the rest of the lecture, and then we'll get into the lab. All right. Any questions or comments on the backup types, the cluster in a box, the cluster across boxes, the physical to virtual, the network load balancing, clustering, failover clustering? You should have some idea at this point in the lecture of what they are and why they exist and where we would want to use them. Because next week we have quiz 2, right? Quiz 2 is scheduled for week 6, and there will be some questions on there that will you'll have to know some of this stuff. All right. If there are no questions, I'm going to stop my video, the recording, and then we'll take a short break and come back at 9 o'clock or 10 o'clock. All right. All right, well, welcome back. It's 10 a.m. So I'm going to share my screen again and get jump back into it. So here we go. All right, so if you were to ask everybody, how important is security? Everybody would say that's a 10, right? On a scale of 1 to 10, security is the most important, one of the most important things that we can do in setting up and managing both the vSphere environment or any environment for that matter. If not, it certainly should be a 10. But what the reality is a lot of times security is applied after the fact. You know, it's one of those things that we come back to when we've done everything else, right? We design our system, we create all this custom software, we get everything working, and then we come back and say, well, now how can we make it secure? It's kind of like if you were to build a house, you wouldn't want to think about security in the last phase of the building process. It'd be better to build it from the ground up securely, right? You could do the reinforcements, you could do the areas that could have points of failure. You'd want to make sure they're beefed up pretty good. We would do all that prior instead of after. So we can look at security kind of the same way we look at the high availability, right? So we can look at it on the host machine. We can look at it from the vCenter server, right, which is our main management application in vSphere. We can look at security of the individual VMs, and then we can look at the security of the applications that are running in the VMs. All right. So just like anything, and if you've ever had any conversation about security, they always talk about layers, right? The castle, the ancient castle or the medieval castle system where we had layers. We had the moat, and then we had the alligators in the moat, and then we had the drawbridge, and then we had the guards, and then we have the inner and the outer, and all these different towers. It's all designed for layers of security. The same concept is true in our vSphere security. All right. So whenever we talk about security, we inevitably have a conversation about the AAA. And the AAA is the authentication, the authorization, and the accounting. So with our AAA, can somebody define for me, what is authentication mean? What does that mean to you? Open my chat. Okay, so Louis, you said verify. What specifically are you verifying? Okay, who you are. Verify a trusted user, the individual. Okay, so a really good statement to define authentication is you are who you say you are, right? So the most common authentication, like how do we authenticate into our ESXi system? We put in our username and password, right? Root, and then our CNET 2021. Okay. And then just for filling out here, what is authorization? What does that mean? Somebody in your own words, tell me, what is authorization? Just pop it in the chat. Okay, Jose says, what are you allowed to do? So when we're talking about authorization, we're pretty much talking about access, exactly, and permissions. So can you access the information? And if you can, what are your permissions on it? Can you read it? Can you write it? Can you create it? Can you delete it? So that's authorization. Okay. Now how in our system, and today we're going to create a file share, and we're going to do some grouping, and we'll give the group permission, and then we'll add a single user and give them permission as well. So their authorization will be based on the permissions that we set on the file share. Okay. And then accounting, what does accounting mean? What does that refer to? Okay, listing, what do you mean by listing, Frankie? Anybody? Okay, good. Alan said keeping track. So this is like our audit trail. So the accounting is referring to, can we see who logged in? Can we see what permissions they were able to use? Can we keep track of who accessed what resource at what time and who utilized it, right? Like who is on the server, who is logged in, right? So like I can come into this system here. Let me go into Apache, and I can see in the settings where are the active connections. I can also see the history. So I can see who worked on their server when and how long they were on there. So the Apache system gives me a list of who did what when, which is very important. You know, when we start having if there's a problem or if there's a breach or there's some sort of system error, we can look it up. Okay. So authorization, authentication, and accounting is in security terms, it's sometimes referred to as the AAA model. So authenticated means you are who you claim to be. Authorization means what permissions do you have. And then accounting is all actions are tracked and logged for future references. All right. Now, authenticating the ESXi host is required. So when we connect to our system, there's only a handful of ways that or accounts that are on there. So we can see this in our ESXi system. So let me log on. And if we come into our host machine and then manage, there's a tab here that says security and users. And this will show us the acceptance level. Then here's our authentication. We could join this to a domain to authenticate against a domain. And then our certificate. So we're using our self-signed certificate. We could import a trusted certificate from a certificate authority, a CA. We can either build our own with our own certificate authority, or we can purchase one from a internet certificate authority and then import it. Then this shows us our users, which for now we only have one user, the root user, and they're an administrator. Okay, and then we have roles that we can set up. We say we could do a new user, right? Create a new user that only has the ability to view what we're doing in our VMware ESXi system. Okay, so and then we can in lockdown mode, well, what users we can make an exception, say we're going to lock this server down, but only our administrators can still work on it, but the users can't do anything, right? So when we're looking at ESXi, there's a lot of ways to kind of deal with that. Okay, so if we go into the host and then look at the local users and groups tab, we can see that. Now this is the older vSphere client. The web interface has almost the exact same look and feel. Now you can also use the command line interface to access our machines as well. So for example, I can come in and use PuTTY. So I'm just going to pick a random, I don't know whose server this is, 38. I think that's Salazar's. And I can log on as root. And I can get, now remember, VMware uses a Linux kernel. So this is just showing me everything in Linux. So if I come in here, well, actually, let me do a history. You can see that when I updated your license, I ran these commands here. Okay, and then ran it twice for some reason. But you can see that I could do things here. So I could create users. I could remove users. I could do anything that I wanted to in the command line, as well as the web-based GUI with the security and users. So I can, in the users, I could create a new group. I could do whatever I wanted to. All right. So here's using PuTTY, and I can connect to the machine using those features as well. Now, to use PuTTY, I remember a couple of weeks ago, I had you turn on the SSH server. So by default, that was turned off. And that's for a security reason, right? If we don't want somebody to be able to get into our machine using the secure shell, we would turn it off. And that's when we do that on a system, that's known as system hardening. So system hardening is where we turn off unnecessary services and features that we know we're not going to use. So if we know we're not going to use SSH, why have it on? It's just an extra possible area that could be compromised. So, to harden the castle, to fortify, we turn off all those extra things. So here's root, where you can log in, you can create a new user. So there's all these commands that we can do this from the secure shell as well. We're not really going to do anything in the secure shell. We're going to use the graphical user interface for all the stuff we're doing, but you certainly could do this. So if you're in a large environment, you may find that working in the shell may be faster and you're able to script it a lot easier. Okay. So there's that. Here's where you can use your Macintosh machine to connect to your SSH using SSH, where you just open a terminal and it will automatically use SSH built into your Mac OS 10. All right. Now, ESXi can also connect to existing Windows Server Active Directories for user authentication. So we could connect our ESXi host to our Active Directory domain. And why would we want to do that? Well, one of the biggest reasons is because we don't want to create user accounts, one on our host machine, one for our mail server, one for our file share, one for ESXi, one for all these different things. Let's have one account that we can use. That way we can manage it from one place. So we can change the password, we can change the settings, we can change the permissions, we can change all this stuff, the auditing on it. And that way we can see when this user logged in to the system a lot easier. So managing domains user account is easier using Active Directory because you're using a centralized security authority, which is easier to work with than going into each individual ESXi host machine. So once we attach the ESXi to our domain, then any user account we create in the domain will work and the permissions will come across. Right? Now, the second part of the AAA model is authorization. And this encompasses access control mechanisms that allow for local access or network access. Now, out of the box, ESXi comes with a firewall that is designed to control traffic into or out of the host. Now, this gives the administrator an additional level of control over what kind of traffic can come in and out of the system. So there are certain default ports that are open, TCP 443 for our SSL communication, DNS, UDP 427 is for the common information model and the service location model. And then TCP 8000 is used for vMotion, and then port 22 is for SSH. So if I come back over here into the services, we can see what services are enabled. So here we have the direct console UI, the load-based terminal, and then SSH is running, the syslog server, and then the vCenter agent is also running. Everything else is stopped. So we could come in here and set those up however we wanted to do that as well. Right, so the firewall is built in to the system. So here's where we can see the firewall under the security profile, configuration security profile, and it will tell us what ports are open and which ones are closed. All right, another key component in maintaining the security of our vSphere environment is keeping everything updated. So with patches and keeping everything up to date, typo. I always hate when I see a typo in my notes, but I'll fix that later. And the main component for that in vSphere is the update manager, right? The vSphere update manager, which is VUM. And that's the tool that updates our system, both the hosts and the virtual machines. So here's basically the security model where we have our users, right? Joe, Mary, and Bob. They're in the white website operation groups, which is the role of the web ops. They can turn on the VM, they can open a console, they can configure the media that the virtual machine connects to, but that's it. They can't, go into the settings of the virtual machine other than the CD media. They can't, add users to this group. They can't do anything other than what we assign them to do. So, the VMware model, besides setting it up like we're doing as server admins, the users need to access these systems so that they can run them, so that they can access them, right? So if they're doing stuff on the virtual machine, they need the proper permissions for it. And then the last A in AAA is for accounting. And ESXi can capture all information performed on it into its system logs. So every host server runs a syslog daemon, just like Linux, that captures those events and logs them for future reference. Now, one thing with log files is they will eventually eat up all your hard drive space. So normally there's a routine that runs on a regular basis that will delete your oldest log files. If you need to keep these files for, say, some sort of regulatory compliance, like if you work in a hospital and you need to show who accessed this, virtual device for the hospital 5 years ago, you may want to do some log capture. So that's where you would do the syslog to a permanent system. So you would probably archive your logs. All right. Now securing, so that's how we secure the host, the ESXi host. So now let's talk about securing the virtual machine. And that's the same as if we were securing the guest operating system. So the first area to look at is the network security policies of the network to which the VM is attached. So the key security settings for that would be the promiscuous mode, which means the network will respond to anybody. The MAC address changes, right? A lot of times people will change the MAC address to spoof that it is from another system. So we can fool like our firewall or our routers. Sometimes we'll have, especially with our wireless, we can set it up to allow approved MAC addresses. Well, if someone changes their VM's MAC address to one, if they're able to capture a packet that shows what the approved MAC address is, then we just change ours and guess what? We're approved too, and away we go. And then force transmit. Now, VMware recommends keeping all these policies set to the reject mode. So these are all rejected or turned on. These modes are turned on to reject promiscuous mode, MAC address change, and force transmits. Right? The other thing we can do is keep our virtual machines updated. Right? Just like a regular machine, we need to make sure our virtuals are updated. So we can do that by using the same patching strategy that we use on any of our other machines. If we have the vSphere Update Manager application and program running, we can use that to patch our VMs as well as the ESXi host. We can use our Windows Update, Windows Server Update service, the WSUS service, to update our Windows machines. We can go into our systems and turn on our security features that will allow us to keep our systems up to date and so forth. All right. So that's all I want to talk about regarding security for the virtual machines. Now, I'll be real straightforward with you. In this class, we're going to talk about security, but we're not really going to turn up the screws on securing our environment, because whenever we have security, we lose a little bit of comfort, right? So when we say this system is more secure, it sometimes shows itself in that it's not as easy to work with. So some of the things we're going to do is actually, if we can't ping or if we can't communicate between devices, one of the things we'll do right away is disable or turn off the firewall. That way we eliminate, well, maybe the firewall is blocking ping, right? Our ICMP packets are getting blocked by the ping server or by the ping firewall. So we'll turn those off just to ensure connectivity. Because at this level, we just want to make sure things work. And then we'll come back and we'll secure them later, which we will do to some degree. All right. So I want to show you a video. There's a video here that, let me open the link.
Atera includes everything MSPs and IT pros need in one.
So this video is going to describe what we're going to do in our lab. Now, some of these systems or some of these setups, they're going to do kind of in one step. I prefer, especially for this first go at Active Directory, that we break it into its component parts. So we'll do Active Directory, which there's a checkbox that installs DNS automatically. So we'll leave that like that. And then we'll come back and we'll do DHCP as well. So let's watch this video real quick. Hopefully you can hear it. If not,
you're watching the IT Taster channel. I'm your instructor, John. And in this video, I'm going to show you step by step how to install and configure Active Directory domain services in Microsoft Windows Server 2019. So don't forget, if you haven't subscribed to the channel already, please hit the subscribe button to receive alerts of new content. I'm also around on social media too, so again, drop by and say hello. I'll leave the links below the video. So with that said, let's go on over to the server and get started. Okay, so let's begin by logging onto the server. Now this server, by the way, is a standalone server, and all I've done is install Microsoft Windows Server 2019 and a few updates, and that's pretty much it. Now, before we begin,
all right, so to do this, we need to make or create a clone of the WinServer parent and rename it to WinServer-DC for domain controller. I'm going to open up the lab file in just a minute, once we're done with this video. But the other thing I want to mention is I did this, what on? I've created a video where I do the entire lab today. And if you get stuck or you get lost or, you don't want to ask a question or whatever, just watch this video. And it just shows, here's the lab video here of me going through every step in today's lab. Okay, so this way you can refer back to it. All right, now you might be asking, why would I do that? Why would I take the time to put an hour-long video or 53-minute long video on the network for you to look at? And I'm just going to be totally transparent here. Your lab midterm is going to look very similar to today's lab. So I want you to be able to reference back to these things so that you make sure that you understand what's going on here. All right. So let me start this back up.
Active Directory domain services. There are a few pre-installation checks that I want to quickly run through. Now, I do have a video on the IT Taster channel that covers initial installation and configuration of Windows Server 2019 that you might want to look at, and I'll leave the link below. So now we're in Server Manager, and I'm going to click Local Server. The first thing I want to do is take a look at our network configuration. We can see at the moment the server is set to receive an IP address from DHCP, and that's something that I don't want. I want the server to have a static IP address. So I'm going to click the link and then go to our Ethernet properties. IP version 4, properties, and I'm going to use a static IP address, which in my case is going to be 192.168.1.1.1. I'm going to stick with a default class C subnet mask. I'm also going to assign a default gateway at this stage. In my case, 192.168.1.254. I'm not going to assign any DNS settings at the moment. Here, I'm just going to click OK. Close that down. And the next thing I want to do is give our server a meaningful name, because by default, when you install Windows Server, the host name that the server is given isn't the most user-friendly to work with. And it's something that's really important to get right at this stage. We don't want to try to change our server name after we've installed important roles like Active Directory. So we'll click that, change, and I'm going to call my server server1. OK. We'll click OK again, and of course we do need to restart the server, so we'll do a quick restart now.
Hi there, welcome to Forward. Come on in. I'm Dr. Nate Favini. I'm our med.
Okay, now that the server's restarted, I'm going to log back in again. I'm just going to review my configuration. So I'm going to click local server. As we can see, the server now has a host name of server1, a static IP address of 192.168.1.101. So we're now ready to proceed with the installation of the Active Directory Domain Services role. To do that, we need to click Manage, click Add Roles and Features. And this starts the Add Roles and Features wizard. This first screen basically just tells us what the wizard does and a few important reminders, like making sure the administrator account has a strong password and that we've reviewed our network settings and installed Windows security updates. So we can just click Next. We need to select role-based or feature-based installation and click Next. The Server Manager is designed to manage multiple servers. So if we had more than one server, we would simply select the appropriate server from the pool and click Next. Now I only have one server, server1, which is already highlighted, so I simply need to click Next. We need to select the server role. Now it is important, if you are working with multiple servers, just to make sure that you have the correct destination server selected. I'm going to select Active Directory Domain Services, which is the role I want to install. We need to click Add Features because there are some additional features that we need to include, and click Next. On the Select Features screen, we can stick with the defaults, which include Group Policy Management, and click Next. This screen just gives us some more information about what Active Directory Domain Services is and what it does. Now, I do have some videos on the IT Taster channel that give a little bit more of an in-depth explanation, and I'll pop the links below in the description. Now, there are also some important things to note. It tells us that to help ensure that users can still log on in the event of a server outage, install a minimum of 2 domain controllers for a domain. We're also reminded that Active Directory Domain Services requires a DNS server to be installed on the network, and this means a Microsoft DNS server. And if we don't have one, we'll be prompted to install the DNS role onto this machine. And finally, we're given some additional information about Azure Active Directory, Microsoft's cloud technology. We need to confirm our installation selections. Now, some roles and features do require a restart of the server, and we can actually tick this box to give Windows Server permission to restart the server automatically. We can also export our configuration settings. We can now click Install to proceed. The installation of the binary files is now taking place. Now, this is going to take a little while, so I'm going to speed things up a little and join you when this is complete.
To support local restaurants, we've been to every city, including Little Rock and even Worcester. And tonight,
The installation of the binary files is now complete. And the wizard tells us that additional steps are required to make this machine a domain controller. We need to promote this server to a domain controller. I now need to select the deployment operation. Now, this is a brand new installation of Active Directory domain services. So I need to click Add New Forest. I now need to specify the root domain name. This is the very first domain that is created in our brand new Active Directory forest. And this needs to be entered in the form of a fully qualified domain name. Now, one suggested method is to use a subdomain of a publicly registered domain name. So, for example, in my case, I might use something like training.ittaster.com. ittaster.com is my publicly registered domain name. Now, alternatively, you will see people using what are known as local or dummy domain names. For example, ittaster.local. Now, this kind of domain name is fine for a lab where you're testing, but it's not a good thing to use this type of domain name in a production environment because you can encounter problems with things like certificates. Now,
So we're going to use CNET.lab, which is a dummy domain name. It's not an internet approved domain name.
I have a video that explains this in greater detail, and again, I will leave the link below. So I'm going to follow the suggested method of using a subdomain of my publicly registered domain name, which is training.ittaster.com, and click Next. I need to select the functional level of the forest and root domain. Now, functional levels determine the characteristics and functionality of Active Directory domain services and the features available in the forest and domains. And also, very importantly, it also affects the server operating systems that can be run on domain controllers. Now, the forest functional level sets the minimum level of Active Directory domain services functionality for all domains and all domain controllers within those domains. I'll say that again, it sets the minimum level of Active Directory domain services functionality for all domains and all domain controllers within those domains, whereas the domain functional level sets the ADDS functionality level for all domain controllers within the domain. So you cannot set the domain functional level below the forest functional level, but you can set it higher. Now, in Windows Server 2019, the highest forest and domain functional level that you can set your server to is in fact Windows Server 2016, because there have been no significant changes. Now, it's also suggested good practice to set your forest and domain functional levels to the highest value that your environment can support. But you do need to be really careful when changing things like forest and domain functional levels. Do your homework first. Make sure that your environment does properly support it, because it can cause serious problems if you set this incorrectly. Now, as my server is running Windows Server 2019 operating system, it's the only server that I have in my test lab also, so I'm going to leave the forest and domain functional levels set at the highest value of Windows Server 2016. Notice DNS is ticked by default because it's an essential ADDS service, and also the global catalog option, because our very first domain controller must be a global catalog server. And finally, we need to specify a directory services restore mode password should we have problems and need to carry out a directory services mode restore. and click Next. At the top of the screen, you can see we have an error that says a delegation for this DNS server cannot be created. And this is because it's a brand new installation of Active Directory, and we don't have a dynamic Microsoft DNS server at this stage. So we can just click Next. We need to verify the NetBIOS domain name assigned to the domain. Now, NetBIOS is a protocol that isn't used that much these days. In fact, it's a pre-Windows Server 2000 technology. The NetBIOS domain name has defaulted to training, so I'm going to leave the NetBIOS domain name set at that and click Next. I'm going to keep the default locations for the ADDS database, log files, and sysvol folders and click Next. We have the opportunity to review our selections and click Next. Windows Server needs to run some prerequisites checks before Active Directory domain services can be installed on this server. And this could take just a few moments to run through. We can see that all prerequisite checks have passed successfully. Now we do have a few warnings below, but this is to be expected with a brand new installation of Active Directory domain services. So we just need to click Install to begin the installation. Now Active Directory domain services is now being installed, and this is going to take a little while, so I'm going to leave it running and we'll return to the video when it's completed.
Hey, Adam Bazalgette here, three-time PGA Teacher of the Year. I've got just one question for you. What if
the installation has completed and I'm now ready to log into the server. But notice I'm now logging into the training domain using the domain administrator account. I'm back in Server Manager, and we can see that we have an Active Directory domain services tile, but we also now have a DNS tile as well. And if we go back to local server, we can see that server 1 now belongs to the training.ittaster.com domain. And if we go to tools, we can see that we have some useful tools like Active Directory users and computers, which we'll look at in other videos. Well, that brings us to the end of the video. I hope you found it helpful. Please give the video a like if you did, and don't forget to subscribe to the IT Taster channel if you haven't already to receive alerts of new content. And also, I'll leave the links to the other videos I mentioned in the description below. I'm also around on social media too, and again.
All right, so that's what we're going to do in today's lab. So let me turn on the lab so you can see it. And I'm going to open the video file I created just so you can, because I want to step through that a little bit.
All right, good afternoon. I wanted
Let me come into Zoom, share screen. All right, so here's the video I created. I'm going to fast forward through some of this.
just do a had recommended is if you open it in a new window,
That's not
you're
correct.
going to have better mouse support.
You don't want to
Some
open a
of
new
you-
window. You want to open in the new
I'm
browser
going to come back
console.
into the data store.
So I just show you how to
Walk
create the
through this.
clone, and notice I changed the backgrounds.
Normally that will put your mouse in the right spot. So it's still way off.
So if that's the case, just close it. And let's try this open browser console. That's the one. Yeah, this is the one, the open browser console. Yeah. See, and then that keeps it inside of your area here. So now your mouse is going to be much more usable. So I'm just going to come into my Ethernet adapter and make sure I'm on, I'm set to obtain automatically. And I'm going to get rid of that DNS setting that I had in there last week. So we don't need that. We need this to get the DNS from our domain server. Okay, so let's do that. And until we bring up that server, we're not going to get an address. We're going to get a PIPA address, which is the automatic private IP address. So if I come into IP config, it's got an IP from my router, but if I release this and then renew it, it's going to time out and I'll get a PIPA address. Okay, so that's there. I'm going to shrink that. So now it's just down here in the corner. And let's go take a look back at our router. And it looks like the copy and the disks are done just fine. So now let's go back into the data store. And we're going to go into the Win server. All right, so that's the video I created. So if you get lost or if you need any kind of how-tos, I go through the entire lab and do the entire lab in this video. So I wanted to make you aware of that. And then let me open today's lab file. Lab 5. Then here's the file here. So it's going to preview it. I'm going to download it. I always like to download these and open them on my machine. And then enable editing, right? So you can actually write in here. So this first section here is just the connection. Connect to your ESXi server. You're going to make a clone of WinServer parent, and we're going to name it WinServer-DC. So you should be able to, if you don't remember how to do that, go look at last week's lab, because that's where I had the step-by-step screenshots for how to do that. The other thing is make sure that this server only has one network card. Last week, we had 2 network cards in our routers. This is not a router, so we only need a single network card. Okay, and then once it starts up, rename the computer to server. Just like the guy showed in the server manager, you click on the name and local server, make yours server, and then change the IP address to 192.168.100.3, 255.255.255.0, leave the gateway blank, and then for the DNS, just put the local loopback address, which will, when we install DNS, it'll do that automatically, but I always like to make sure that's in there. Then once it restarts, you're going to create a new Active Directory domain service role. Functional level is Server 2016. That's as high as we can go. Make sure to install DNX by leaving that box checked, and then the global catalog. So this is going to install, and then you need to promote it, right? Just like we saw in the video. And when that's done, we're going to install DHCP. We're going to create a scope. And then we're going to create some users. And then we're going to create a file share. And then we're going to test connectivity from Windows 10. So Windows 10 Client 1, which makes sure it's on the VM internal network, which it should be. That's where we left it last week. Okay. And once you get on there, you're going to change your computer from a work group to a domain membership in the CNET.lab domain. So when you get to that part, if you have questions, let me know. Then there's just some basic questions here. So these are on the server 2019, you're going to have to look up the password policy, which is where when you're in this gpmc.msc, this section, that's where you can get the answers to these questions. Okay. Then I want you to briefly define the difference between a work group and a domain computer membership. You can Google that, or you can look through, Microsoft site or whatever you want to do. Then the DNS information. Once everything's connected, you'll have two entries in your DNS. So if you go into your server manager, manage DNS, and you poke around, you'll find the two names and then the data that's on there. And then I just ask you, what are the 4 steps for DHCP, which if you've taken networking, you well aware of that. If not, you can do a search on that. All right. So any questions on today's lab, what we're going to be doing? Anybody? Not at the moment. Okay, yeah, that's true. I mean, you haven't even started it yet, so it's kind of hard to get going. But if you get stuck, and if you want to, you could probably play this video that's on the week 5, and just follow along. You should be able to walk right through this lab without any problems. Okay, so I do everything in the video. So if you want to just kind of take your time and okay, do this, pause the video, go do it, do this, pause the video, do that. That would be a great way for you to learn how to do some of this stuff. You could also just read the lab and do it like you normally do, and then just ask me questions. All right. If there are no questions, I'm going to turn you loose on the lab. I'm going to stop today's recording because I have a video of the lab separate already, and we'll go from there. All right.